Hi everyone, welcome to the next session of training. So till now I have explained about SAP BW, so like how SAP BW has started, then what are the objects we have in SAP BW, what is the SAP BW architecture, and what is the data flow in BW, how to create different modeling objects, and then how to load data into BW, and how to create reports on top of BW objects. So in the coming sessions or in the next sessions, I'm going to explain about SAP BW on HANA. So I'll explain what is HANA and how SAP BW on HANA is different from SAP BW on normal database, and we'll also see how you can convert your BW system into a BW on HANA system, and then we'll also see some mixed scenarios. So when I say mixed scenarios, how can I take data from BW to HANA and HANA to BW? So we'll see all those things in the next sessions. So in this session, I'm going to give you introduction about SAP BW on HANA. So what is BW on HANA? Whatever the system or whatever the BW system we have right now, so that system is, you have your SAP BW system. The first thing we have to remember is SAP BW is an application. Okay, so when we say it's an application, it cannot store the data. It doesn't have any physical storage. It will give you an interface to maintain your data in an effective manner in the database. So what is the database that we use for a BW system? We can use any database that we have in the market. So you can use Oracle, you can use DB2 IBM database, or you can use Sybase, or you can use SQL Server. So whatever the databases that we have in the market, we can use any of those databases. So you have your BW system and you have your database which supports for your BW system to store the data. And on top of this, you are going to have your BEX suite. BEX suite or tools. So now this is the architecture that we have right now in the market. So here this is a three-tier architecture. So what are the three tiers we have? So the first one is database. So the first basic layer is your database. So this is called database layer. And the next one is BW system, which is application, your application layer. And the last one, the upper one, is BEX suite or BEX tools, which is your reporting layer, a reporting or presentation layer, from where your users are going to have a look at data. So these are the three different layers we have in the current landscape. Okay, and when we talk about the database layer, so this database layer is a normal RDBMS, which is a relational database management system, or we can say it's a disk based database. It's like our hard disk in the laptop, where you can store your data or you can fetch your data. That means you can read the data or you can write the data. Other than that, it cannot perform any activities. It cannot perform any calculations. Okay. So where we can perform those calculations, we can perform those calculations at application layer level. So what happens here is, let's say we have a query, Bex query, where you are having uh, your filters, you have applied some filters and you have created some restricted key figures or calculated key figures. So where those things are going to be calculated? So they are going to calculate at application level. That means at BW system level. Because why they are going to calculate at application level? Because our database doesn't have that functionality. Our database doesn't have that capability. That's why we are calculating those things at application level. So if I have to calculate those things at application level, what I have to do? I have to fetch all the data, all the required data from a database to application, and then calculate those things, then give those to presentation layer. So there has to be lot of data transfer between your database layer, application layer and presentation layer. So let's imagine if my database can perform such calculations. Okay, I no need to transfer data from here to here. I can directly perform all those calculations here and then I can directly send the result data. Instead of sending the bulk data to my application layer to perform the calculations, I can send only the result data from my database to application layer, which takes very less time when compared to sending bulk data. Because see, you might have 50 fields in InfoCube, but in the report customer might need only 10 fields. So what you are doing, we are aggregating the data. So even though customer want 10 fields, to aggregate the data, as your database cannot perform any aggregations, you have to bring all the data to here and then aggregate, then send it to your reporting tools. So let's say you have 10 million records in your InfoCube, and if you aggregate those 10 million records for 10 fields, it might become 10k records. So as a result, you need only 10k records, but you are transferring 10 million records from your database layer to application layer because your database cannot perform those aggregations and calculations. So you can imagine this transferring 10 million records and transferring 10k records directly. So how much improvement we are going to get, how much performance improvement we are going to get. But the bottleneck here is our system doesn't have, our database doesn't have that capability of performing such kind of calculations or aggregations at database level. So that's the reason in today's world, or in today's data warehousing world, we are sending the we are sending a lot of data from database layer to application layer to perform calculations. This is one of the major bottleneck that we are facing with current BW systems. And the other thing is, once you transfer to your application layer, so in application layer, what you are going to have, you are going to have your servers, nothing but your RAM, read only random access memory. Okay, and you will also have cache, L1 cache, L2 cache, L3 caches, which are in CPU. So you will have your RAM and you will have your CPU. So your RAM has to perform the calculations and then send it to your CPU. So that is another bottleneck. So you are going to have your in BW system itself, you will have a RAM where you are going to have your servers. and then you will have CPU. So your RAM has to perform all the calculations, nothing but server, and send it to CPU, from where your reports are going to get the data. So in CPU you will have different caches available. And another bottleneck here is going to be sending data from a RAM to CPU, because most of the times your BW system might have, let's say, 30 GB or some 60 GB RAM, but in real time this RAM is going to be a little less for the system. So that is another bottleneck. So the main reasons or the main issues that we face while transferring data from your database layer to reporting layer is, one is sending data from your database layer to RAM to perform the calculations or aggregations, and the another one is move data from your RAM to CPU, the result data from where your reports will get the result data set. So these are the two bottlenecks we are facing right now in the current market. And the other things with the existing BW architecture or BW landscape is, see what we are doing, as our database has certain limitations. Okay, we are at the end of the day we are giving aggregated data to the users. We are not giving detailed data to the users, because we are storing detailed data in the DSO, and from there we are loading only the summarized data to info cube, on which we are creating reports. That means we are giving reports on the summarized data. Why we are giving reports on the summarized data? Why can't we give reports on the DSO, which has a detailed level data? Because when customers can do analysis on detailed data, they can do a lot of things. They can do a lot of analysis instead of having analysis on summarized data. But why we are not giving most of the reports on DSO is because of performance issues. So if you try to create report on DSO, it will take hell lot of time to display the data in reporting tools. Because same reason, how much amount of data it has to transfer from here to here, obviously it will take time. So that is one of the major reason we are giving reports on aggregated data, that means on info cube. Okay, and the other reason is, see, some customers will accept for that, but some customers says, I don't want all those reasons, I want reports on DSO, or they want reports on info cube which has huge number of records. So in such cases what you have to do, somehow you have to improve the performance. So how can you improve the performance? You can create indexes. So you create indexes at DB level to improve the performance. So that is one additional administrative activity. So whenever you load the data, you have to delete the index, and then once data load is done, recreate the index. Because if indexes are exist, then data loading will take a lot of time. So that's why if you have indexes for any of the modeling object in BW, delete those indexes before you load data and recreate those indexes. So if it is say like 500 or 1k records, then no need to delete the index. If it is say 20k or 30k, more than 20k or 30k records, it's better to delete the index and recreate them. Okay, that is one additional administrative activity we have to perform to improve the query performance in existing BW system architecture or landscape. And the other thing, okay, the other things we have to do at BW level to improve the performances, what we are doing, we are creating multiple layers or multiple levels in the modeling. We have data source, we have DSO, we have info cube, and then if still the requirement is complex, we are going to create multi-providers or info sets. So what we are doing here, same kind of data I'm storing at different levels. I'm storing in my data source, I'm storing in my DSO, I'm storing the same kind of data in my info cube. So what is happening with this? We are going to have a lot of data redundancy in BW system. So when we say data redundancy, data duplicacy. So data redundancy is high in BW system. Okay, because of data redundancy, your database maintenance is going to be too complex. Okay, let's say if you have 10 GB of actual data, okay, then because of this data redundancy, you will have 40 GB data in your database, which needs additional maintenance activities, okay, to have an healthy system. And other thing is, so another concern with this is going to be your hardware cost. You have to buy a lot more extra hardware. You have to invest a lot of money on the hardware part. Okay. And the other thing is going to be, as it is a normal database, sometimes data loading time also will be high. So you will if you are loading huge amount of data, then it will take a lot of time to load the data into BW system. So these are some of the concerns or some of the pain points that customers are facing right now with the existing BW architecture we have in the market, which is having a normal database for BW system. And the another reason is, whatever the data that we are loading to BW, it's not up to date data, because whatever the transactions that business is going to perform today, will load those transactions to BW system today night. That means if they look at reports tomorrow, then they are actually looking at the data that is, or they are actually looking at the operations that are happened till yesterday. So if they are looking at reports today, that means they have data in BW till yesterday. They don't have data that is, they don't have operations or they don't have sales orders that are happened from today morning. So they will get those tomorrow. So we are not providing up to date data to the users or to the customers, because we don't have such functionality. We have a functionality called RDA. Okay, RDA, real-time data access. So the development as well as maintenance of RDA is too complex, and we cannot have RDA for everything in the BW system. We can have maximum for 5 or 6 info cubes. We cannot have RDA for everything, because its development will take time, as well as maintenance also need a lot of effort. That is our other challenge. If customer asks for up to date data or real time data, see, if they execute a report now, they have to see what is happening right now in their OLTP system, or OLTP is nothing but in their source system. So they want to have a look. If they want to have a look at what is happening right now in their OLTP system, which is online transactional processing system, so which is nothing but source system, where they are going to do their business. So if they want to see, we cannot provide with BW. It's not possible. So these are the most pain points that every customer is facing with the existing data warehousing landscape. It's not with BW, it's with all the data warehousing landscapes that are available in the market. So how can we avoid that, or how can we overcome that? Can we actually overcome that? Or can we imagine any database which can perform our calculations, which can perform our aggregations, or which can support for a real-time data access? Can we imagine such kind of database? Maybe not 2 years back, but now it's possible. We can imagine, and it's there in the market as well. So the database is SAP HANA. So HANA stands for High Performance Analytical Appliance. In simple words, HANA is also a database, but with a lot of advanced features. HANA has everything that is available with the advanced technology we have got in the memory or in the technology side. It can be with CPUs, or it can be with your RAMs, or it can be with your hard disks. So it has all the advanced features included in that. So what is HANA? How we can overcome the pain points that we discussed here with the help of HANA database? So first of all, HANA is an in-memory database. So when we say in-memory database, so here for my application server I am using memory 30 GB or 60 GB. However, whatever the database that I am having here, it's going to be disk, normal or hard disk. But when we talk about HANA, your entire database is RAM. So there is no disk involved in your landscape or in your architecture. So your database is RAM. That means if my database is RAM, my database can do everything now. My database can perform calculations, my database can perform aggregations, everything it can do. So there is now this bottleneck is gone. So moving data from your database layer to application layer is gone. There is nowhere now. Okay, and the other thing, so HANA has a RAM as well as HANA has CPUs. So HANA can work as both a database and it can work as your server. That means there is no gap between your RAM and CPU. Both are same now. So this bottleneck is also gone. So you no need to transfer data from your RAM to CPU. Now your RAM, CPU, database, everything is HANA. It can perform all those functionalities that can be achieved using your database, your RAM and CPU. And along with that, HANA is going to be multi-CPU system, multi-CPU as well as multi-core system. So when we say multi-core, let's talk about you have a laptop with 4 GB RAM. Okay, so I can have 4 GB RAM or I can have 2 GB RAMs. Or if you have slots available in your motherboard, you can even have 4 into 1 GB RAMs. So you can either have 4 1 GB RAMs or 2 GB RAMs or single 4 GB RAM. So all these combinations is possible if your CPU is compatible with that. See, if your CPU is a single core system, if your CPU is a single core CPU, then you can have only 1 4 GB RAM. If your CPU is a 2 core CPU, then you can have 2 GB RAMs. If your CPU is a quadra core CPU, then you can have 4 1 GB RAMs. So what is the advantage with multi-core CPUs? So the advantage with multi-core CPU is parallel processing. So if you have a multi-core CPU, then you can have a very good parallel processing at server level. So what we are going to get with the help with parallel processing. So what happens is, let's say you have a cube, okay, which has 4 years sales data. Okay, so if you have a single core system, single core CPU, one thread or one session will be generated to read all the 4 years sales data. Whereas if you have quadra core CPU with 4 1 GB RAMs, each RAM, I mean each thread will be generated for each RAM, so it will divide the data. So 1 year sales data will be read by each RAM or each core you have at CPU level. So reading all the data with the help of one RAM will take a lot of time when compared to reading a subset of data with the help of different RAMs or different cores. So obviously you will get a very good performance with the help of multi-cores. I'll not say you are going to get bad performance, but still this will be good. You will get very good performance. But when it compared to your 4 into 1 GB RAM, this is a slow. You will get a best performance when you have multi-core CPU available. So HANA is a multi-core CPU database. So here I am talking about 4 cores when I say multi-cores. So in HANA you can have 64 core system. Then think about multi-processing, multi-parallel processing, how much parallel processing you can get. And with this 64 core system, you can have maximum of 4 TB or 8 TB system. That means each core can have, how much it can have? So 4 into 4 into, let's say approximately 1000 GB for TB. So it's 4000 by, let's say 60. So each core can have 64 GB RAM. So think about a database which has 64 cores CPU and each core has 64 GB RAM. Think about processing, how fast it can read the data. With this kind of configuration, HANA can read 2 billion records in 1 second. So this is the kind of performance you will get with the multi-core CPU, a database. So that is what HANA.